All right, Algebra 2, we're going to show you one more thing in this chapter. I promise two things. This is going to be something considered enrichment, but I do want to go over it and have you practice it only because it's going to practice factoring, which we haven't done in quite some time. Okay, so here's the thing. We can take a linear system, right? So that means we have a line. You see those diagonal and horizontal lines here, and a quadratic. That's those U shapes. Okay, so when we're dealing with two lines, we had three things that can happen. We still have three things that can happen, yet they're very different here, right? What can happen is we can find two solutions, right? The line can go through that U shape in two places. It could go through right at the vertex as a horizontal line like this, or there's a chance that they don't touch at all, like this diagonal line and that parabola right there. Okay, so those, we don't have special names for them, so nothing really stressful about this. All right, so here's what we have is, here's some graphs, and we're saying, all right, so this is what we have, and this is the graph. All right, so the parabola, of course, negative x squared, so that's that blue U shape that you see here. And we've been through the whole thing, how to graph it, how to do all these things. So I'm not going to review any of that because I don't want to review any graphing. We just did some of that. And then we have the line with a positive slope. So that's our red line here. And all we're doing is we're finding the points in which they share. Okay, so if you have a graph, that's all we're looking for. Which numbers are the y values of the solutions of the system? So careful here, it reads as y values. So that's 6 and 10. So that would be D way over here. Okay, so of course this is trying to catch us and try and do something about x values, y values. All right, so I have another one here. The graph is already done. Okay, you do the same thing on your page here, and we're just trying to find out where do they cross. So now we have parabola that opens up, a line that goes up, and we find those 2 points in which they cross. Okay, so what am I going to ask you to do is to do this by substitution, and this is how we're going to practice our factoring that we're going to work with here. So I'm going to take a negative x squared minus x plus 6, set it equal to x plus 3. And what I really want is everything on one side, and that's what makes this possible. So what I might do is subtract the x and subtract the 3, because I want everything on one side. And I know what you're thinking. You're like, hold on. You always told us to try and get x squared to be positive, and right now it's negative. So I'm going to just divide it by negative 1. So here's what I have. I have x squared plus 2x minus 3 equals 0. Okay, either which way, in most years, I probably would have said, let's move the x squared, even though it's all three terms. But you know what? We can deal with this either which way. So now that I have everything on one side, I'm hoping that it's factorable. So what factors of 3, right? Because I had 1 times 3, subtract to give me 2. Well, the only factors of 3 can be 1 and 3. And if I want to get positive 2, it's positive 3 and negative 1. So remember we do x equals 1 equals 0, and x plus 3 equals 0. So x turns out to be 1, and x turns out to be negative 3. Now notice I'm doing something extra here, and if those are the x values, I still have to find out what y value makes this happen. So if x is 1, I'm going to plug it in right here, and that means 1 plus 3 is 4. Let's do that again. If x is negative 3, we're going to plug it in right here again. So if I took negative 3 plus 3, I get 0. So these are the two ordered pairs, right? So we started solving with x values, and then we plugged it in to get y values. Now, what should happen is if I plug negative 3 into the quadratic up here, I'm going to get exactly the same thing. Right? And that's what's pretty cool about it. Remember, they have to share these. That's what a system of equation uses. All right, so that was a linear and a quadratic. Same thing can happen with two quadratics. All right, so we're going to start off the same way. We're going to set these two guys, since y is equal to y, we're going to set them equal to each other. X squared minus x plus 12 equals x squared plus 7x plus 12. All right, so what I am going to do this time is take everything from the left. I'm going to add x squared, I'm going to add x, and I'm going to subtract 12. I'm going to add x squared, I'm going to add x, and I'm going to subtract 12. So 0 equals 2x squared plus 8x plus 0. So I'm going to leave that part off. All right, and this one gets to a little bit smaller type of solving, right? All I can do, it's two terms, it's not a special case. So it's a GCF, 2x and x plus 4 equals 0. So 2x equals 0, x plus 4 also equals 0. So x turns out to be 0, comma blank. And if I subtract 4 here, x turns out to be negative 4, comma blank, right? I got to find out what the other half of these ordered pairs are. Okay, so if I plug in 0, right, so 0, 0, 12, that one was pretty easy. I'm not going to lie. That one was pretty easy. Now let's take negative 4. Negative 4 squared plus 7 times negative 4 plus 12. 16 minus, what do we got here? 28 plus 12. All right, 16 minus 28. That's what, a 1 there and a 2 there. It's negative plus 12. Hey, it turns out to be 0, doesn't it? Okay, so they happen to be x and y intercepts. All right, so let's take a gander here. All right, that's all I want you to be able to do with this, guys. We're not going to spend a whole ton of time. Like I said, I'm not going to put any of this on the test. I just wanted you to be able to see what's happening here, right? This time I'm going to add x squared and subtract 5, add x squared and subtract 5. All right, it looks like we're going to get rid of these, so we're going to have another GCF, 2x squared minus 4x equals 0. So 2x and x minus 2, remember using our GCF. And looks like the other one's going to be a factor. Just trying to look ahead here. 2x equals 0, so x equals 0, comma, what's the other half of it? Here we got x minus 2 equals 0, so x equals 2, comma, what's the other half of it? Both quadratics, but I'm still going to stick to this little smaller second one. If I plug in 0, 0 squared, all right, so that whole thing 0 plus 5, so I get 5. And if I plug in 2, this is negative 2 squared plus 5. So negative 4 plus 5, I get 1. Right, so I don't need to graph these to figure it out, although we could. All right, let's take the last one here that we'll do together. And hopefully by now you at least have somewhat of an idea. We remember how to graph or how to factor. All right, so let's move everything to one side here. Let's add x squared and add 5, add an x squared and add 5. Just thinking way ahead there. Here's to my 2x squared minus 4x plus 10 equals 0. All right, kind of nice review here as we have everything going on. What do I want to do with this? I want to divide it by 2. Right? It doesn't matter if I'm going to factor it, if I'm going to complete the square, if I'm going to quadratic formula. I want to try and reduce this as much as possible. So minus 4, so 2x plus 5 equals 0. All right, so we have a lot of things going on. Factors of 5 that add up to 2. Well, that's not going to happen. So let's try this. Let's try complete the square. X squared minus 2x plus blank equals negative 5 plus blank. And let's go here. X, half of negative 2 is negative 1. 1 squared is 1. So that means I have to add 1 to both sides. Now I get negative 4. And remember, to finish solving here, we're going to take the square root of both sides. So I have x minus 1 equals plus or minus I square root 2. Whoa, no, not square root. I. 2i. Holy cow. What just happened? Oh, I got an imaginary. Remember, that means that this just isn't going to work. Okay, so typically we would finish it up by adding 1. So 1 plus or minus 2i. But what that means for these two U shapes is, right, they're just not going to cross. Okay, there is no real number in which they're going to cross. Okay, so I want to make sure we got through, and we did finally get one of those, and we get a chance to review something other than factoring because we've been away from that for a little while. Okay, you can see that we can also throw in some inequalities, greater than meaning above, and I'm sorry, greater than on the bottom meaning above, and then less than meaning below, and then we could look for a double shaded area just like we had before. So feel free to peruse those. We'll pick some of these to do for homework. If you think you got the idea, go ahead and work ahead. You can see I have some answers listed on the side as well.